Perfect. Hello, everyone. This is Vasdev Gullapalli. I'm an SRE. I'm here to present site reliability engineering at Qualcomm for Gerrit. This is the agenda we got. So altogether, we have 12 slides, not many. I wish I can complete this in 30 minutes. Let's see how it goes. I'll introduce the team. We'll talk about dependency map, why Gerrit, and why Gerrit is critical in Qualcomm to begin with. That's a dependency map. We talk about weekly deployment process, what sort of tunings we did to handle the growth. We did some upgrades this year, and we did some good data validation steps as part of the process. We'll deep dive that a little bit more. We have CI/CD pipelines designed to handle Gerrit replicas in K8. So we have a few slides around that. I'll wrap it up with challenges and future opportunities. Who are we? We are software engineering IT. We have a global team, primarily located in US and India. We manage multiple applications, and Gerrit is one of them. The primary purpose of the team is to ensure whatever the applications we support, they are reliable, performant, and available 24/7. SREs, we inherit 24/7. It's given. So we try to design our architectures or the systems which are cost-effective and scalable. That's our base for anything to begin with. We try to proactively, we try our best to prevent the service interruptions. Our tech stack is Chef for on-prem, K8's Helm, Python is our go-to, AWS. All the latest and greatest Devops application, the technologies are being used in Qualcomm. Dependency map. As I said, Gerrit is critical for Qualcomm. Why, right? Let's take a look at the plot. There are three sides to it. One is for Gerrit to be functional, we need a lot of IT services to be up and running, right? That's why, that's one side of the story. The second side of the story is for SREs to bring Gerrit up, we have some functional dependencies. Say, for example, Helm, Chef, right? All these dependent applications should be up for Gerrit to be upgraded or any sort of maintenance to happen. So in that way, the final side of this is Gerrit is very critical because there are so many internal tools in Qualcomm which are integrated with Gerrit. So it's not just a developer impact, like he or she cannot push the changes. That's not the case. Like if Gerrit is down, we are talking about a direct business impact. That's why it is one of the most critical business applications most critical for business in general. It has a direct impact to one of our flagship devices. We have multiple Gerrit instances, and most of the slides are related to the most popular one. Because of the proprietary reasons, I'm not going to talk about the instance. High availability. Based on the need, if there is a need, we spin up instances with high availability. And we have multi-primaries and global replicas. We have around 12 global replicas configured. The spread across bare metal, AWS, and K8 clusters. Now the weekly deployment, production deployment happens on Monday, but the process in a way starts on Tuesday. So we identify the artifacts, Nasser and team provides us the artifacts, what has to be deployed. Along with that, if there are any internal tools which we have to deploy as well, they'll all be considered on Tuesday. We create a checklist, we deploy them on a non-production environment, and trigger some testing. The next slide talks about testing. We'll deep dive a little bit more there. So that's on Tuesday. Then we review the results. And if it is a go or a no-go, based on that, we go to the next step. Most likely, let's say, assume the happy path, they're all go. So on Thursday, we do the pre-deployment sign-offs. Customers' communication will be sent out. Stage deployment, another non-prod environment, the stage deployment happens. Here also, more round of testing will happen. If everything looks good, on Friday is a buffer day. Qualcomm recommends not to do any deployments on Friday. So it's a buffer day if any spillovers and stuff like that. So on Monday, as I said, the deployment day. Testing suites, we spend some good amount of effort in this area to ensure we are providing a stable system for our users. So different test suites here: 5 iteration, concurrent, endurance, developer load simulation. So it's like functional testing, performance testing, load testing, and developer load simulation is an interesting thing where we came up with. We deep dived what the developers are doing on day-to-day basis, and we sort of mimicked it on which projects they are doing more reads, writes operations, what sort of writes are happening. We mimicked all of that into a test suite, and we trigger that so that our systems believed that, oh, developers are doing some activity. That is nothing but the developer load simulation. Based on that, we run some iterations, right? Functional wise, reads and writes are happening. We have some use cases. They go one after another. And based on that, we collect the metrics out, whether it is heap related data, whether the latencies or the throughput, all these will be measured. If everything looks good, then the deployment is a go at the end of the day. So 30, 50, 100 concurrent testing is nothing but the performance testing. So 30 users, 50 users, 100 users, clients in a way. So doing reads and writes, again, we measure the metrics, how this new deployment is functioning. If everything looks good, it's a go. Endurance, it only runs when, I would say, when there is a critical thing happening, like a significant change is getting deployed, then we run the endurance for 24 hours. Like, it's like highs and lows. And at the end, we collect the data and see how Gerrit is performing. If everything looks good, again, it's a go. So that's the strategy there. Gerrit upgrades. As I said, we did a lot of Gerrit upgrades in the recent times, which is, A and B. We consider 2 instances for the slide, A and B. There are more than 2 instances, as I mentioned earlier. A was running on 2.7, and now it is running on 3.9. We did a hop in between. We upgraded to 3.5, and then we went to 3.9. For B, because now we have a lot of experience, right? 2.7 to 3.9 with a hop. With that experience, we believed that we can do a 2.12 to 3.9 jump. That's what we achieved here. Challenges. This is not a joke. We tried our best to do it successful, and we did without a rollback, obviously. So 20 version jumps for A, 13 version jumps for B, because the starting point is 2.12. There are multiple toolings are needed because we want to speed up the process. As I said, business critical application. If you're requesting our community to, hey, can we extend the downtime for an hour? There is a huge pushback. It's not possible. So we did some lot of automation around how to speed up things, how to do the global deployment. That's where the tooling needs came in. And there is some technical debt. We addressed that as well as part of the process. Highlights, the team did hundreds, maybe. I know I am exaggerating, but multiple upgrade rehearsals and rollback rehearsals. That shows how critical the application is. We spent a ton of time on this. Finally, we also consider data validation. That is also a critical piece of it to ensure that all the data is validated before the users can consume the application. That's the idea there. Value delivered wise, 3.9, Gerrit did an amazing job. Like, it is reliable, performant, stable, and the UI, UX, we had a positive feedback from the user community across the board. Data validation, I touched earlier. So as part of this, some of this data is like, we're talking about the biggest instance. So we have 5 million changes in that instance when we did the upgrade. So to do the validation, 5 million is a big number, right? So we consider two areas. How can we do the data validation? Through the API route, through the disk route. So we consider both of them. Before starting the upgrade, we ensured that the required data is collected. And then we did the upgrade before the user starts using it, and we validated the data in between. So some of the snippets are here. And if you look at it, we developed a few tools, collect py and validation py. We run this, and before the upgrade, we run the collection py, and after the upgrade also we run the same script. Looks like the number of threads used in this snippet was 40. That means the 40 threads are running the Gerrit queries. For validation, similar effort, but the thread is like 60. So if you look at the output, yay, no differences. Data validation is successful. So it took like 6 minutes, looks like. So that's what, when I mentioned earlier, the speeding of the process, that's what we achieved at the end. Continuous integration. This is where, this is only for replicas in K8s, right? So our primaries are running on bare metal. Only the replicas were deployed in K8s cluster. So the whole process starts with building an image. So whether the changes are coming from the Gerrit version itself or any changes in general, which goes to an image. So it has to be built first. So this section talks about that. And then the required image will be built. Once it is built, there will be a tag saying that it's built. That's a tag. So it has to be tested, right? So now we build a tag with the new, there is a new image now with the build tag. Then another job will kick in saying that, hey, I have a build tag now. Let me test it. So it deploys on a CI environment, it tests it. If everything looks good there, then a new tag will be generated saying the tested tag. Then the downstream job runs again. One more job runs and says that, okay, I have a tested tag now. Let me do whether it is qualified for a release. So again, some more tests run, and if it is qualified, then the release tag will be created, right? So on the right-hand side, if you see, there is a tag information and UAT, stage, and prod, right? They're all in unreleased state. So note on that point. So because there is a queue, there is a message in the queue now, which says that, oh, there is a tag with UAT as unreleased, stage as unreleased, and prod as unreleased. Let's go to the next slide because it's a deployment now. So now here we have some gates in place on purpose because we don't want to deploy something which is not well tested, and we follow the fundamentals that path to prod, test, stage, and prod should be continued and properly vetted across the board. So an SRE goes, and right now it is, this step is the left-hand side, the step is manual, right? We click on a button saying that, hey, fetch the message and do the deployment. So the queue, in the earlier job, the queue already has that message, right? So the metadata is already there. So based on that metadata, the job realizes that, oh, UAT is in unreleased state. So let me consider that and deploy that. So that will be consumed and it will be deployed on UAT. Again, some more tests will be run automatically. If everything looks good, then the UAT will be updated as pass. So that's the last bit here. It says UAT pass. Now the message says that UAT is pass, stage is unreleased, prod is unreleased. Then the next day or whatever, SRE again has to do the click. We did it, like we can automate it maybe in the future, but right now it is manual, at least the clicking the button wise. So there's the checks and balances we went with. The same process repeats. This time it is stage. The same process repeats again for prod. So somewhat automated with the manual clicks. Yeah. So challenges, this whole process, during this upgrade primarily, we realized that H2 cache management was a little challenging for us because the caches are growing significantly on the disk. we try to remediate the problem by some monitoring, alerting in place. Whenever the file diff caches are growing to an extent, we sort of clean them up. So that's why it is critical right now, sort of red, because there is an user impact. Users are seeing, because of the growth, users are seeing some slowness at their end, and there are some errors, failures as well. Replication, we are using push replication. I heard Matthias mentioned that they're using pull. Maybe we should consider that. We'll see. We'll internally discuss. There are some concerns there. NFS is a challenge. Performance-wise, we already hit the performance limits recently. So to address that issue, we had to separate the primaries and replicas on one of the critical sites globally, because NFS, our volume couldn't able to handle the load. So we split the traffic, and the downside to that is one more replication endpoint, because it's a new site altogether according to primary, because we had to separate it out. Consolidations and upgrades, as I said, we have multiple Gerrit instances, right? So we have to consolidate. And the process of consolidating, I heard from Daniel, there is a plugin which we can leverage. Maybe I need to discuss with him offline, but right now, with the knowledge we have, consolidations are tricky. And consolidations and upgrades may needed to consolidate an instance. Upgrade could be needed. So that is another challenge which may run into in future. Documentation, Gerrit user or admin documentation is somewhat. That's what my team believe. Hey, we need to improve something in there. Whenever even the users, we hear someone saying, "Hey, this documentation is talking about this." I don't understand what that means. So sometimes we don't either. So that's the state. Maybe there is some improvement. Finally, turnaround times, upstream support. Somehow we are expecting, whether it is repo discuss or in general, immediate responses are expected. But on some of the tickets we raised, I think they're still open for at least a year or two. Future opportunities. As I mentioned, it's a challenge, but we have to continue. We have to do the consolidation so that we'll have the maintenance cost will be reduced. There is an OpEx tied with it, so we are considering it as an opportunity here. Primaries are not containerized today. They're all running on bare metal with Chef. So the plan is go with containerizing next year. Lifecycle management, upgrades, plugins, that is in the roadmap. Whenever a new release happens, obviously we want it to be running with the latest and greatest. Java upgrades, we are on Java 17 now. As Matthias mentioned, we have to consider Java 21 upgrade. Looks like there is a performance improvement as well there. GC changes, we made some changes. We are still using parallel GC. The plan is to go with ZGC. And to do that, we'll leverage some of the testing suites and ensure that it is performant. There are JVM tunings, which is tied with that. For HPA, vertically scaling, as we are growing, the growth, the usage is also increasing significantly. So we have to manage them. The KH replicas wise globally with either HPA, horizontal pod, auto scaling, or the vertical. That's all I got. Thank you. Ponch, how do you simulate developer activity? Do you use any particular tool? It is, we are using JMeter in general for any load related testing. But for simulating developer activity, it is a lot of insights. We are looking at Splunk, we are looking at Datadog to understand what the developers are doing, at what time they're doing it, what projects are they touching, what sort of replication is getting triggered, what sort of mirroring activity is happening. So all that is considered. And then we are coming up with the use cases and timely use cases. That's how we are doing it today. Ponch, how do you analyze the data to simulate developer activity? Do you have custom scripts to do it, or you have any tool? Is it anything that can be open sourced? Right now, they are not open sourced. We have custom scripts built. They're all in JMeter, tied with JMeter somehow. We can think about open sourcing. Shane, how do you determine that things look good? Eyeballing the metrics or something more rigorous? Good question. It's sort of both. We have, so the QA job, what it does is it generates the baseline first and the deployment happens, and then we have new data. So what we do is it's a big Excel. It diffs the results for each use case and gives a report to us that, oh, these are all in red. That means we have some maths, crazy maths going on. Nasser helped us out with those. It's crazy. So it's, when you see red, it highlights red. So when it is red, we feel like, oh, there is a performance degradation. Why? Then we manually do it today. We take it to the next level because there are some networking gotchas. Everything plays a role. We have to find balance, consider everything, and then take a call whether it is a go or a no-go. So that's how it is happening today. Yeah. Yeah. If I dig into deeper, it's going to be much crazier. So I'll leave it there. And I created a Confluence doc just to talk about that math. How? So, sorry. Are you Son Matthias, are the data validation scripts open source? They are not today. We can think about open sourcing. Yeah, the same Ponch. Can the data validation scripts be open source? It is a common issue and they'll look interesting. Yeah. What kind of issues did the validation find? Yeah, copy approvals I can think of. Maybe Nasser can chip in more. The question is also coming from him. So there are multiple, Kaushik is also here. He helped us out to fix the data issues. Lot of ACL related, like, the code review, I would say the code reviews +1s, +2s, or they're not carried over properly. Some data validation discrepancies were identified primarily over there. And, our developers community is like, hey, we have to address these. So yeah, we spent few sprints around this and we were successful at the end. Why only the replicas in K8s, not the masters? Because it is relatively complicated. Why, right? So our primaries, they're not just designed for Gerrit. They have, on the host, there are more jobs running, like mirroring. There are other activities happening around Gerrit. So we have to offload one at a time to Drakkar before we touch Gerrit, or we can go other way, and we have to design it properly. It is much more complicated than a replica. So that's why we went with replicas first. Now we have some confidence that we can go with the primaries as well. We are in the process.